These shapes are called cardioids, so it's r of theta equals a number here, it's 1 plus sine of theta, and theta is going to run from 0 to 2 pi. So by adding 1 in this case, we'll get an interesting graph piece. By adding 1, the sine of theta, it's positive almost everywhere now for the value of r, except when it just touches the theta axis, r equals 0 at 3 pi over 2. So that's going to end up making a somewhat interesting shape, even though this is a smooth graph. Let's go ahead and take a look. So it starts out, gets bigger and bigger as it gets to pi over 2, that's its maximum, and it's going to be symmetric, coming back around, eventually it'll get to pi, and then it's decreasing the whole time, but when it gets to 3 pi over 2, something interesting will happen. You end up with this corner called a cusp. Even though this is a nice smooth graph, sine of theta, you end up with this sharp point. Now that sharp point will turn into something else when you have 1/2 instead of 1. We now have a negative region again, and it's going to do something a little bit interesting, so let's go ahead and take a look at that. So again, starts out, it's going to reach its maximum at pi over 2, it's going to come all the way to pi, and then it's going to get to, not quite sure what that theta value is, but it's going to end up with r negative. And so instead of a cusp this time, it's going to make a little loop-de-loop inside of itself. And there you can see the r value is negative. When it's going to get back to here, it's going to be positive again, and then it's going to rejoin where it started. So we did r of theta equals 1/2 plus sine of theta, 1 plus sine theta, and here's 3/2 sine theta. This one's not as interesting, but you get to see kind of a pattern. So now there's not even a 0 touching point. It's all strictly positive values of r. Let's go and see what that looks like. So same general shape on top. We're going to get quite a bit higher here. We're going to get to r equals 2.5. It's going to come back down. And so when we had 1, it was a cusp. When we had 1/2, it was a loop-de-loop with r negative. And here instead, it's just going to make a little kind of inward dent, I guess. And it's going to come back and join where it started when it gets to 2 pi. Now to put this all together, we're going to actually vary that parameter value from 0 all the way up to 2. So we did 1/2, we did 1, we did 3/2. Now we're going to go all the way from 0 to 2. We have our sine graph here that's going to slowly translate upward as alpha gets bigger and bigger. And we're going to see how that changes. So this isn't a cardioid. And one thing to point out here right now, this is the circle graph that was done in a different video. And normally, if you just want to go around that circle once, you'd go 0 to pi, because you end up going over it twice. But here we're doing 0 to 2 pi, because essentially those two loops are going to separate. So let's see what happens there. So immediately after going above alpha equals 0, starts to separate, and the inner circle became a loop-de-loop. When we finally get to 1, that loop-de-loop closes, forms the corner. And then when we get past 1, it's no longer a sharp corner anymore, no longer a cusp, and it just kind of rounds out in this little dent in the circle. When we get all the way to 2, we're going to get to r equals 3 at the top here, and r equals 1 at the bottom.